Okay, so get ready, because today we're diving deep, really deep,
Oh,
into the
right.
universe's biggest mysteries.
Oh, cool.
It's incredible to think
Yeah.
we've sent these machines, like Voyager 1 and Voyager 2,
Uh-huh.
billions of miles away, hurtling through space. They're carrying golden records with messages from Earth. It's like
Oh,
we
wow.
tossed a message in a bottle into the cosmic ocean, hoping that someone, somewhere, might find it.
Uh-huh.
But here's the thing. Even with these amazing feats of engineering,
Yeah.
we're still just barely scratching the surface of what's out there.
Right.
So, are you ready to explore the edge of our solar system and beyond?
Absolutely. Let's go on this journey.
Welcome to Cosmos in a Pod,
yes.
our space and astronomy series.
I love it.
So,
Okay. Yeah.
Voyager 1 and 2 launched way back in 1977.
Yeah.
They're like time capsules, right?
They are. Yeah. You can think about it that way.
Not only carrying this record of humanity,
Yeah.
but also acting as our eyes and ears in this
Yeah.
vast expanse of space.
That's right.
It's pretty wild to think that Voyager 1 is now the farthest
Yes.
human-made object. It's cruising through interstellar space.
That is correct.
That's amazing.
It crossed the heliopause.
The heliopause.
Yeah. The boundary where the sun's influence fades and interstellar space begins.
Oh,
And we actually have received data from that region, giving
wow.
us unprecedented insights into this mysterious realm.
That's so cool.
It is.
And New Horizons, the plucky little probe
Yeah.
that gave us our first close-up look at Pluto.
Yes.
It's still going strong too, isn't it?
It is, yes. But even these incredible travelers, they will eventually fall silent.
Oh.
By 2038, New Horizons, its energy generator, will no longer be able to power its system.
Oh.
And it will just drift silently through the void.
It's kind of sad.
It is a little bit.
Makes you realize just how limited
Yeah.
our current technology is.
Yes.
Even the Parker Solar Probe,
Right.
our fastest spacecraft, is confined to our solar system.
Exactly. Even though it uses the sun's gravity to slingshot itself to incredible speeds, its path will eventually lead it to be consumed by the very star
Oh, wow.
it's studying. To truly break free and venture into interstellar space, we need revolutionary technologies.
Like, what kind of tech are we talking about?
We're talking about things like ion drives.
Ion drives?
Yeah, they use electrically charged particles to create thrust,
Oh, what?
or even nuclear propulsion.
Nuclear propulsion.
Yeah, which could provide the immense power needed to traverse these vast distances.
Okay.
But even then, the dangers are immense.
You mean like running into a rogue asteroid or something?
Well, even something as small as a grain of sand, called a micrometeoroid,
A micrometeoroid.
traveling at immense speeds could cause catastrophic damage to a spacecraft.
Yeah.
The vastness of space isn't exactly a friendly environment.
No, this sounds terrifying, like a minefield.
It is.
And we haven't even talked about the regions of space that we can only theorize about.
Right.
The Oort Cloud.
The Oort Cloud,
Yeah.
thought to be this colossal sphere of icy objects, the outermost boundary of our sun's gravitational influence.
Okay.
So think of it as a vast icy shell surrounding our solar system.
It's like a cosmic suburb,
Kind of, yeah.
full of icy surprises.
Yeah, it's way out there.
And speaking of surprises, what about rogue planets?
Rogue planets.
Those wanderers without a star to call home.
Yes, rogue planets are fascinating.
They are.
Imagine planets, perhaps Earth-sized, drifting through the galaxy untethered to any star.
So like a planet without a sun.
Exactly.
That's crazy.
Some estimates suggest there could be more rogue planets in the Milky Way than stars.
Wait, really? More rogue planets than stars.
It is mind-blowing.
Yeah.
That's incredible. And it opens up some intriguing possibilities.
Like what?
Some scientists speculate that some rogue planets,
Right.
despite lacking a sun, might retain enough internal heat
Okay.
to have liquid water beneath their surfaces.
Liquid water.
Yeah.
You're saying there could be rogue planets out there with hidden oceans?
It's a possibility, yeah.
That's incredible.
It raises the question, could life, as we know it, or even forms we can't imagine, exist on these wandering worlds?
That is some serious science fiction stuff.
It is.
But it could be real.
Exactly. The universe is full of surprises.
It is.
And that leads us to another intriguing question. What about life around other stars?
Okay.
We're constantly hearing about exoplanets, planets orbiting other stars.
Yeah.
Are there any that look promising for life as we know it?
Okay, I'm all ears. Where should we start our exoplanet hunt?
Well, the closest star system to our own Alpha Centauri has a planet called Proxima Centauri b.
Proxima Centauri b.
Yeah.
It's in the habitable zone, right?
Right, it is. It orbits within the habitable zone of its star, Proxima Centauri.
So are we talking about a potential Earth 2.0?
Well, not so fast.
Okay.
While its location is promising, Proxima Centauri is a red dwarf star.
Red dwarfs.
Yes, and they're notorious for intense stellar flares.
Oh, okay.
These flares are like sudden bursts of energy that could easily strip away any atmosphere.
Wow.
Proxima b might have, making it a pretty harsh place for life to gain a foothold.
So not exactly ideal.
No.
It's incredible how diverse
It is.
star systems can be.
Yeah.
Are there any others that have caught your eye?
Let's jump over to the Sirius system.
Sirius.
Yes.
Okay.
It's a fascinating study in contrasts.
Okay.
Sirius A is a brilliant blue-white star,
Okay.
but it has this companion, Sirius B, which is a white dwarf.
A white dwarf.
Yes.
That's the remnant of a star like our sun after it's burned through most of its fuel, right?
Exactly. It's incredibly dense.
Wow.
The leftover core of a star that shed its outer layers.
Oh, wow.
So in the Sirius system, you've got this powerful contrast.
Yeah.
A star in its prime and its companion.
Right.
A ghostly reminder of what's to come for stars like our own sun.
It's like a cosmic time capsule showing us the past and the future of stars. It really is, yeah.
Speaking of vast timescales,
Yeah.
what about our own galaxy, the Milky Way?
The Milky Way.
I've always been fascinated by the supermassive black hole at its center, Sagittarius A.
Sagittarius A is a real behemoth.
It is.
With a mass millions of times greater than our sun.
Wow, okay.
The region around it is chaotic, densely packed,
Okay.
where stars whirl around the black hole at incredible speeds.
Like a cosmic dance?
It is a cosmic dance on a grand scale.
Black holes are often portrayed as these monstrous things that gobble up everything in their path.
Well, not exactly.
Okay.
While black holes have immense gravity,
Uh-huh.
they don't suck things in like a vacuum cleaner. Objects have to get pretty close to be pulled in.
That makes sense.
Yeah,
But it still sounds pretty intense near a black hole.
it is.
What about the parts of the Milky Way further out?
Well, as we move outward from the core,
Okay.
we reach the galactic halo.
Galactic halo.
Yeah, this vast region extends far beyond the familiar spiral arms of the Milky Way.
Oh, it's home to ancient globular clusters.
Globular clusters?
Yeah.
What are those?
Imagine densely packed groups of hundreds of thousands, even millions of stars.
Oh, wow.
These clusters are some of the oldest objects in the galaxy,
Really?
offering us a glimpse into the Milky Way's distant past billions of years ago.
Wow. It's like looking back in time
It is.
to the galaxy's ancient beginnings.
Yeah.
It's amazing how much diversity there is within our own galaxy.
There is.
But I'm curious, what lies beyond the Milky Way? I mean, what's out there between galaxies?
Well, beyond the realm of galaxies, we encountered these vast regions
Okay.
of near total emptiness
Yeah.
called cosmic voids.
Cosmic voids.
Yes.
Yeah.
Think of them like giant bubbles in space.
Giant empty bubbles.
Hundreds of millions of light years across.
What's the significance of these voids?
Well,
They sound kind of boring.
they might sound empty, but they're far from insignificant.
Okay.
Studying these voids helps us understand the large-scale structure of the universe. It's like looking at the scaffolding upon which galaxies and clusters of galaxies are arranged.
So it's like the negative space in a painting,
You could say that.
helping to define the overall composition of the universe.
Yeah,
That's a cool way to think about it.
it is.
But if they're mostly empty,
Yeah.
what's in them?
They're not completely empty. They
Okay.
do contain a few galaxies scattered here and there,
Okay.
but their vastness is what makes them so intriguing.
Okay.
They tell us a lot about the distribution of matter, and even dark energy.
Dark energy. That sounds like something out of a science fiction novel.
It does, but it's a real phenomenon.
Okay.
And it's thought to be responsible for the accelerating expansion of the universe.
Right. The universe is expanding.
It is.
I thought it was already infinitely large.
Well, it's vast, but not infinite.
Okay.
And it's not only expanding, but that expansion is getting faster and faster.
So everything is moving further and further apart at an increasing rate.
Yeah,
That's wild.
it is.
What's driving this acceleration?
That's where dark energy comes in.
Okay.
We don't fully understand what it is,
Uh.
but we know it's a repulsive force that counteracts gravity on a cosmic scale.
So like a cosmic anti-gravity pushing everything apart.
You could say that.
Wow.
It's a profound mystery, one that keeps cosmologists up at night.
Speaking of things that keep me up at night,
Yeah.
what about black holes?
Black holes?
What happens to the stuff that falls into them?
That's a question that has puzzled physicists for decades.
Yeah.
Once something crosses the event horizon of a black hole,
Uh-huh.
it's gone forever.
Gone.
Not even light can escape.
So it's like a cosmic trapdoor leading to who knows where.
Essentially, yes.
Wow.
The conditions inside a black hole are so extreme that our current laws of physics break down.
Yeah.
We need a new theory of quantum gravity to really understand what happens at the singularity,
You okay?
the point of infinite density at the heart of a black hole.
It sounds like we're pushing the boundaries of human knowledge
We are.
when we try to comprehend black holes.
Yes.
But before we go down that rabbit hole,
Okay.
what about the search for life beyond Earth?
Ah,
Any exciting developments there?
absolutely.
Okay.
The search for exoplanets, especially those that might harbor life,
Right?
is one of the most exciting areas of astronomy today.
We talked about Proxima Centauri b earlier,
Yeah.
but are there other promising candidates out there?
There are actually quite a few.
Okay.
Thanks to missions like the Kepler Space Telescope and the James Webb Space Telescope,
Yeah.
we've discovered thousands of exoplanets.
Thousands.
Yes, some of them appear to be rocky planets like Earth
Okay.
and orbit within the habitable zones of their stars.
You're saying there could be other Earth-like planets out there with oceans, continents, maybe even life.
It's certainly a possibility.
Wow.
And even if we don't find actual life,
Yeah.
studying these exoplanets helps us understand the diversity of planetary systems
Okay.
and the conditions necessary for life to arise.
That's fascinating.
It is.
What other areas of research are you particularly excited about?
Another area that's really heating up is the study of gravitational waves.
Gravitational waves.
Yes.
Those are ripples in space-time
Uh-huh.
caused by massive objects like black holes colliding.
Exactly.
That's amazing.
And we're now able to detect these waves
Okay.
using incredibly sensitive instruments like LIGO and Virgo.
Wow.
These observations are like opening up a new sense, allowing us to hear events in the universe that were previously invisible to us.
So we can now listen to the symphony of the cosmos.
You could say that.
That's incredible.
It is.
What kind of things are we hearing?
We're hearing things like black holes merging, neutron stars colliding, and even the echoes of the Big Bang itself.
That's crazy.
These observations are confirming some of our theories about the universe
Okay.
and also revealing new surprises.
Surprises like what?
Well, for example, we've detected black holes far more massive
Okay.
than we ever thought possible, challenging our understanding of how these objects form and evolve.
So it seems like the more we learn, the more mysteries we uncover.
It does seem that way.
But all this research,
Right.
it's not just about satisfying our curiosity, is it?
Yeah.
Does exploring the cosmos have any practical benefits for us here on Earth?
That's a great question.
Yeah.
And the answer is a resounding yes.
Okay.
Space exploration has driven countless technological innovations
Okay.
that have improved our lives in countless ways.
Can you give us some examples?
Think about satellites, for instance.
Satellites.
Yeah, they've revolutionized communication, navigation, and weather forecasting.
Okay.
We rely on them for everything from GPS to satellite TV.
That's true. I can't imagine life without GPS.
And did you know that medical imaging techniques, like
Right.
MRI and SAT scans, were initially developed for use in space exploration?
Wow. I had no idea.
It's true.
That's pretty cool.
Yeah, and the list goes on. Advancements in materials, science, computer technology, renewable energy. All these fields have benefited from the challenges and innovations of space exploration.
So, exploring the cosmos isn't just about pushing the boundaries of human knowledge.
Yeah.
It's also about pushing the boundaries of what's possible here on Earth.
Exactly. And perhaps even more importantly, space exploration inspires us to dream big, to push beyond our limits, and to strive for a better future.
It reminds us that we're part of something much larger than ourselves,
Yes.
connected to this vast and mysterious universe.
And that connection, I believe, is something truly profound.
Well said.
Thank you.
I think we've covered a lot of ground in this episode.
We have.
From the silent voyages of our spacecraft
Great.
to the mind-boggling concepts of cosmic voids and dark energy.
Yeah,
It's been quite a journey.
it certainly has.
And it's just a glimpse into the vastness and wonder of the cosmos.
It is.
Before we move on,
Okay.
any last thoughts for our listeners?
I would simply encourage everyone to keep looking up, to stay curious, and to never stop exploring.
That's good advice.
The universe is full of wonders waiting to be discovered.
Welcome back to Cosmos in a Pod as we wrap up our deep dive into the mysteries of the universe. I'm still trying to wrap my head around all the incredible things we've discussed.
It has been a whirlwind tour, hasn't it?
It really has, from those silent Voyagers, our spacecraft venturing out into the unknown, to those mind-boggling cosmic voids and that force we call dark energy.
Yeah, it's been quite a journey.
And who can forget those rogue planets, those wanderers without a star drifting through the galaxy?
Yeah.
The thought of them maybe even harboring life in hidden oceans, it just sends shivers down my spine.
It's certainly a tantalizing thought.
It really does feel like every answer we find just leads to more questions.
It does.
Which makes me wonder, what are some of the biggest unsolved mysteries that astronomers are grappling with today?
Well, there's one that has been a real head-scratcher for decades: the true nature of dark matter.
Dark matter.
We can observe its effects, how it influences the movements of galaxies and clusters of galaxies, but we still have no clue what it's actually made of.
It's like this invisible hand shaping the universe, but we can't see the hand itself.
That's a great analogy.
It is.
And then there's dark energy, which is even more baffling.
Right.
We know it's driving the accelerating expansion of the universe, but its origins and true nature remain completely shrouded in mystery.
It's almost like trying to understand the engine of a car by only looking at the exhaust fumes.
Exactly.
Yeah.
These two enigmas, dark matter and dark energy, are fundamentally intertwined with our understanding of how the universe began and where it's ultimately headed.
They're like the missing pieces of a giant cosmic puzzle.
They are.
So figuring them out could completely rewrite our understanding of the universe.
Absolutely. And then there are questions that delve into the truly mind-bending realms of physics and cosmology.
Okay.
Like, are there other universes out there? What happens at the singularity of a black hole, where all known laws of physics seem to break down? And of course, the age-old question: are we alone in the universe?
Those are some truly profound questions.
They are.
It makes you realize how much we still have to learn.
That's the beauty of science, isn't it?
Yeah.
It's a never-ending quest for knowledge, driven by our insatiable curiosity and a desire to understand our place in the cosmos.
And it's a journey that requires collaboration, innovation, and a willingness to push the boundaries of what we think is possible.
Absolutely.
Absolutely.
Astronomy is a global endeavor, uniting scientists from all corners of the planet to share their knowledge, expertise, and a common passion for unraveling the secrets of the universe.
And with powerful new tools like the James Webb Space Telescope, it feels like we're on the cusp of a golden age of discovery.
We are.
Who knows what incredible breakthroughs await us in the coming years?
It's an incredibly exciting time to be an astronomer.
It is.
And who knows, maybe someday some of those mysteries we talked about today, those questions that seem almost unanswerable, will be solved by a future generation of scientists, perhaps even someone listening to this podcast right now.
Well, that's a thought that gives me chills. I, for one, can't wait to see what the future holds for space exploration. But for now, I think we've reached the end of our deep dive.
It's been a true pleasure sharing this cosmic journey with you.
The feeling is mutual. And to our listeners, thank you for joining us on Cosmos in a Pod. We hope you've enjoyed this exploration of the universe's greatest mysteries. If you're eager to delve deeper into the cosmos, don't forget to follow and subscribe to Cosmos in a Pod and our YouTube channel for more cosmic adventures. Until next time, keep looking up and never stop exploring.